Hello and welcome, guys. So this is going to be a video about dependency inversion principle. It is actually one of the probably the most popular principle I use all the time, at least in web development. And a lot of principles are built on top of it, like for example hexagonal architecture or onion architecture, which is the same, are built on top of it, which are ports and adapters. And yeah, so this is a must learn. And as usually, I will try to use here real world examples. So chances are, I would say like 100% that you're going to use something similar at your job. So stick around, it's going to be very helpful and interesting. All right, so let's just jump right away to the code. I will show you the example, the problem with it, and how we can solve it, and then we'll deduce from it what is dependency inversion principle. So we have an order service which will process refunds from our clients, and we're using Stripe in this example. So we have a pretty much simple function which takes some charge ID, which will probably come, I don't know, from either database or from web directly. Most likely we will get some information from web and then fetch some data and get the charge ID from database. Then we pass in this data into the Stripe client, and everything is pretty much straightforward. Yeah, when we will use it, we will create Stripe client, we will inject it into our other service and just hit refund, right? Let's take a look at the Stripe client. I'll just put it on the side. So this is a mock, right? But we imagine that this is a npm package or whatever, right? We installed it and we have dependency on it. So far, this service is kind of all right. And yeah, it works. It does the job it's supposed to do. However, the problem comes in when, for example, our manager comes to us and says that we should be able to process not only Stripe payments, but also payments from PayPal. So we added a PayPal client, and now we should be able to handle both. So in order to do this, we can obviously inject here PayPal as well, the same way we did Stripe, and then add here some kind of if-else statement or switch case, right? But this is not how it should be done, because we will be violating other solid principles, like for example open close. If you're interested, you can check out my previous video. I will leave a link in the description. So essentially, what if we have not only PayPal, what if we have like 10 more payment services, right? So you're gonna write a switch case for 10 scenarios. So yeah, obviously that's not gonna work. So we need to inject actually directly here the correct implementation. And to do this, we need to separate our order service with the client, right? We need to place some layer in between. And this is essentially what dependency inversion principle is, right? We are inverting dependencies. So our order service will depend on some payment interface, like payment processor interface. We will add a type, and then we should be able to create PayPal client and inject it, right? We cannot inject it because we are still using Stripe client in our constructor, but we will replace it with payment processor, and now we use payment processor. And the same we will do for our Stripe client and for our PayPal client, right? So as you can see, we inverted dependencies. Now we are injecting payment processor. Payment processor is an interface, and each our client has to implement this interface. And we have no errors, everything works. So did we solve the problem? And the answer is yes, in a way, because for this specific scenario, we solved the problem, right? We have a payment processor which has a refund payment, and it takes this payload and returns the DTO, right? And both of them do implement this interface, right? They have charge ID, amount, refund, and the same for PayPal. But in real world, that's not going to be the case, right? Who said that Stripe and PayPal will have the same charge ID, amount, basically the same inputs, the same outputs, and overall even the same method? So what if we have a different PayPal client, right, which doesn't have a refund payment, right? We cannot implement the interface. Let's try it, right? We will get an error, right? Because, for example, if the client has a refund method and then instead of charge ID it takes, I don't know, transaction details and uses email and transaction ID, and instead of amount, we actually can refund a percentage of payment, and you can specify, I don't know, 150%. So what if the input is completely different? What if output is completely different as well? So we are not returning refund ID amount, right? Not what is specified in our interface. We are returning completely different payload. All right, let's have a look how we can solve this problem. All right, actually, let's start with the diagram because jumping into code might be a bit confusing. And the first step we should do is actually define the terminology we're going to use in our application, in our business logic. So for example, let's assume Stripe uses something for refunds named charge ID, right? They require it. Can we use charge ID in our application and have like same column in a database? Yes, we can. But ideally, we should use something which our clients, like people who use application and we understand, right? This is something called ambiguous language, but I'm just jumping ahead of myself. So let's assume we're going to use transaction ID in our application, regardless of payment service we're going to use. So Stripe uses charge ID, we don't care about it. So we have transaction ID. Then every refund will have amount, right? Then on the backend, let's assume we will add a timestamp, or maybe it will come as well from external service. Like, for example, transaction and amount will probably come from web request, right? And then we will have maybe reason. So I just added some like columns here, right? Just as an example of something that might be coming from the web, or we might on the backend then add some additional like metadata, whatever. The next step we're going to do is actually define a payment processor. Like I showed you in a wrong example, there was nothing wrong with that, right? We need to invert dependencies, and this is how we actually going to invert them. And we will say that every payment processor must have refund payment method, and it will take the refund request, which I just talked about, right? So this is essentially what's coming from external, right? External input. And then we will provide refund context, which we will take from most likely our storage, right? Some information about this payment, which we are refunding, which we have already information about, right? We probably stored it in a database. So this is essentially going to be our dependency inversion layer, right? And now our Stripe and PayPal and whatever payment service must implement this interface. So since I showed you in the previous example, PayPal client itself, right, which like let's say NPM package, or we're making just API request to them, they have different inputs. We need to add another layer. We need to add an adapter, which will convert our request, context, whatever, to what they expect, right? So essentially here we will do mapping of the request specifically for each payment provider. And then we will have as well a refund service. And so what we will do in refund service, this will where all the orchestration essentially will happen, right? So the first thing, we will receive the payload, which comes from the web. We will map it and create specific like refund request and prepare like context from the database, fetch everything. Then we will need to determine which payment service we are using, right? So we'll have a factory, which will be returning this payment processor, right? We will, for example, provide to it type, and if type is Stripe, we will return Stripe adapter. If type is PayPal, well, you got the point. And then essentially we are executing this adapter with the payload. And this is it. All right. So I think fairly straightforward. Let's jump into code. Just a brief pause. If you enjoy this type of content or want to watch me live code projects like this, hit subscribe button and ring that bell. It is free, takes 2 seconds, and helps me a ton. As you can see, only a very small percentage of you guys actually subscribe to my channel. Anyways, thank you very much for all the support. Let's continue. All right, so the first thing we need to do is to add interfaces, which our adapters will implement, and our service will then use these adapters. All right, so the first one is refund request with our transaction and amount, essentially data coming from external, then refund context, which is going to be data from most likely storage from the database. And here we will have like a transaction, which I'm returning directly, like this is a example of request to the database, but it's stored in memory, and we're straight away returning transaction from database, but most likely that's not going to be the case. You will need to add some mapping here, right? So once you got the data from database and then you map into the transaction. And the important part here is payment method details. So essentially here we will have all the metadata specific to each payment method, right? So it will contain some fields. For example, for Stripe, we will have this data, but for PayPal, then this will be empty, right? If this was a Stripe payment. So here, once again, we will store all the needed data for each specific payment type. And after that, let's add a response because we need to define response interface as well for our adapters, because we need to separate our business logic, right, from the implementations. So we define a refund response, and each adapter will prepare this response. And I've created a class which will have like a success and error case in case of API failures. So we are creating based on different scenarios. After that, let's move into service. So we will add the payment processor itself, which our payment providers will implement. So we are taking refund request, refund context. Then we are adding the repository, which database should implement. And we adding interface for our factory. So as you can see, everywhere we are using interfaces, we are not injecting specific implementations. We are inverting dependencies everywhere. And then let's add a process refund function. So this will be triggered from, let's assume, controller, right? Refund service. We provide all the dependencies and trigger refund process refund. And as you can see here, we are fetching data from database, the transaction. Then we are creating a specific processor, right? So let's take a look at our factory. As you can see, it's fairly simple. We're just taking a payment service type, which is Stripe or PayPal. It's an enum, and returning specific adapter, right? And then once it's done, we are hitting processor and refund payment with the refund request and context, basically the payload they require, right? So refund payment, and yeah, we all defined it. Now let's take a look at the adapters. So our Stripe adapter, as I said, has to implement payment processor, right? And it does. It has this method already. Then what it does, we create a Stripe client here. It can be done a bit differently, maybe singleton here, whatever, not on every execution, but doesn't matter. So here we are using Stripe client itself, which will make API requests to the Stripe. And in our refund payment method, right, we take in specific payload, which we defined. And then here it's actually pretty straightforward, right? So we provided information from the database, as I mentioned before, so payment method details, and on it we will have all the specific information for each payment method. And we are just taking Stripe charge ID because this is what Stripe client requires. It requires amount and Stripe charge ID, right? Defined here. And yeah, with Stripe, it's pretty much it. Now let's take a look at the PayPal. PayPal is a bit more complex, but it implements the same interface, right? We create once again PayPal client, but the PayPal itself requires different payload. So it requires payment percentage, then requires transaction details with PayPal email and transaction ID. So in order to do that, we need to do some mapping, which we can do here, right? So we calculate payment percentage from request amount, which came from the web. And then in the database, we have a total amount stored. And basically, we calculate the percentage. And in the refund request, we're providing this percentage. Once again, we have PayPal email stored in the database. And we provide as well transaction ID. And this is pretty much it. And yeah, then we need to do some mapping into responses, right? In case of a success, we map into success. If it's failure, we map into failure and return it. So now let's just wrap it up. So our refund service, let's actually create everything. So we will need to create a repository and a factory, processor factory for our refund service. Then we create refund service with repo and factory. And then we just call process refund with some amount, timestamp, like timestamp can be optional, and then transaction, which will be some UUID. And as you can see, right, we inverted all the dependencies. Our refund service has no idea about payment type, and it doesn't even know about repository and the factory. We just defined interfaces here, and everything is being implemented and provided into refund service. So as you can see, transaction repository implements the interface of repository. Our factory implements the interface of a factory. And for adapters, yeah, I already showed you. However, this solution still has some issues. I mean, we are done with the dependency inversion principle, but if we take a look at our adapter, for example, the way we are handling errors, right? It's a refund response, and we are adding a failure here. So we can say that this can, in theory, violate single responsibility principle. I mean, it's debatable, but we are handling refund logic here, and we are handling failure. So we kind of doing two things because we are doing mapping here, but yeah, that's debatable. In any case, as you can see, we don't have that many validations, right? But for example, we had some business rules like payment percentage above 80, we need to return our error once again. Refund response and failure, right? And we will provide here. But this is a specific business rule, and these business rules can be different for PayPal and Stripe and different payment service. And we can't do this in adapter, because adapter is essentially responsible for converting one interface into another. And business rules are supposed to be triggered from service, right? Service is the orchestrator, and he is supposed to, I don't know, create some entity or whatever and do the validations. So how are we supposed to handle this? And for that, actually, I will do it in the next video, talking about Liskov substitution principle. So if you don't want to miss it out, please subscribe to my channel. I hope the dependency inversion was helpful and you learned something new. Thanks for watching. I will see you in the next one.